Okay, let's have a go at sketching this particular curve, y equals 2 to the x, and then we've got variations of it, 2 to the x plus 3, and then 2 to the x plus 3 as the exponent. Now, I think what you shouldn't do with these questions is start putting loads of values of x into this equation and plotting the results. That's a laborious and very time-consuming way. There's a much better way, and it's to examine what happens to the function when x is very large positively and when x is very large negatively. So here's a table into which we can put the results. So our function is y is equal to 2 to the x. So when x is very large and positive, 2 raised to the power of that very large number, so this is going to be very large. So it's going up there. So now let's think about when x is very large but negative. So there's our function again. So when x is equal to, let's say, negative 5, we get y is equal to 2 to the minus 5. Now, I don't want to repeat myself, but this is nothing to do with a negative number. What we've got is that this is equal to 1 over 2 to the 5. So if x is equal to, let's say, negative 100, y therefore is equal to 1 over 2 to the 100. So that you can see as x gets increasingly negative, the value of y is heading towards, well, 0. So we know the curve is heading down there. We need to look now where x is equal to 0. So if x is equal to 0, y is equal to 2 to the 0, which equals 1. Any number raised to the power 0 is 1. So we know the graph goes through this point here. And this point, just for completeness, yes, 2 to the power 1, y is equal to 2. So now I've got the tricky job of trying to draw this graph. Now to a very quick check, at 2 to the power 4, we should be 16. So our point at 4 should be just about up there. So I'll try to aim for that, but no guarantees. Fairly near. They did ask for a sketch, but you get a rough idea of what's going on. Okay, so we've achieved a reasonable result from our investigation of x being very large positively and negatively, and then just get a value and then fit the curve in. You should remember that shape. It's useful to remember this is an exponential shape, 2 to the power x. Now, let's have a look at part B. Well, this is a transformation. And as we're not transforming x itself, we're transforming y. So what we're doing is we're adding 3 to every point of the original curve. So we're taking the point 1 here and dragging it up to 4. And that will happen to every point on the graph. They'll all go up by 3. So it's going to look like this. I've just copied the curve and I've moved it 3 points vertically. So the point that used to be at 0, 1 is now at 0, 4. So this line here is the answer to part B and is the curve y is equal to 2 to the x plus 3. And this is the original curve of y is equal to 2 to the x. So let's have a look at part C. So where in part B we added 3 to y, which effectively is a vertical transformation. This moves the curve up and down. The plus 3, in fact, moved it upwards. So this alteration of x in part C will move the curve in a horizontal direction. But which way is it going to go? Well, hopefully you know and remember that this is one of the biggest elephant traps in this kind of mathematics. With x plus 3, you would expect the curve to move in a positive direction along the x-axis. We're adding something to x after all. But in fact, if you work it out, and when I looked at sine x in a previous tutorial, I proved that it actually goes the other way. So when we add something to x, as we have done here, the curve shifts to the left by 3 units in this case. So I've picked the graph up now, and I have to move the red dot, which is where 1, 0, 1 used to be, and I have to move it 1, 2, 3 units to the left to there. And there we have it. This is the curve of y is equal to 2 to the x plus 3. And that's your answer.